Hi. So a little bit of different environment teaching is, but we're doing solving inequalities now. And so solving inequalities, you've already had a little bit of exposure to hopefully inequalities. And so we're just going to kind of now solve inequalities. So remember, ladies and gentlemen, that you have your less than or equal to, you're greater than, or you're greater than or equal to. And these still apply to what we're doing when we're solving inequalities. So let's think back. So you have your equation, and now you have the inequality. Or inequality. Okay. So what we're trying to accomplish is that we're trying to relate these two that we've already done. So for example, x equals 3 is an equation that we've already know how to do. But what if we did it this way? Less than or equal to 3. See how we're using the inequality sign this time? And let's say we have 5n minus 6 equals 14. And we have 5n minus 6 is greater than 14. Do you see the difference? That one's using the equal sign and this one's using the inequality. So we got to make sure that when we're doing inequalities, we got to have those basic signs to kind of make this an inequality. But we're going to do the same thing as we solved in our equations. We're just going to now make sure that we're doing them with an inequality instead. So, do you remember that, going back to this, that if you had our graphing, so what if I wanted to graph this one here, let's say it was x is greater than 3. What if I wanted to graph that? How would you graph that? Well, you would draw your number line. Here's 3, or here's 0, and we go 1, 2, 3. And do you remember if it's going to be a solid or a hollow? Well, it's going to be a hollow because of the inequality doesn't have an equal sign. So this is going to be an open. In what way is it going to go? Well, in order to do this, maybe you know this off the top of your head, but you can always plug in some values. So maybe is 4 greater than 3? Is 4 greater than 3? Is 2 greater than 3? Well, 4 is greater than 3. But 2 is not. So this is false. So this fails. So we know that it's going to go in that fashion. And remember that 3 cannot be greater than itself. You can't do that. So this does not work. And that's why this is hollow. Okay. That was just basic review of inequalities. So let's now get into the solving inequalities. Okay, so I'm going to take all this out because this should have been review. Okay, so here we go. I want you to note real quick before we get started that this and this, these are very different notations. And what I mean by that, these are parentheses. So I want you to do this. This is not included. These braces, brackets, are included. And what that means is, when we start doing the inequalities, if I had something like this, what we call interval notation, that's another thing I want you to kind of remember, integral, not involved, integral notation. What I mean by that, interval notation, I get the wording correctly. Interval notation means, what if I had something like this? That's your interval notation. It's written like this. That means that between 0 is not included. I can't have something equal 0 because it's not going to work. But I can have something equal to 8. So this is not included, and this is included. So that's kind of what I want you to get used to, understanding this terminology a little bit, is to kind of see where what we're going to be including into our solving. So let's do some solving. Just make sure you kind of see those. You might need to rewind this video to kind of look at this again. Okay, so let's do a couple of these. Well, first one, number 1, negative 4x is greater than 8. Number 2, 4x is greater than or equal to 8. Number 3, 6x is less than 12. Minus 12 this time. Right. Number 4, let's go a little bit more involved. Negative 4x plus 7 is greater than or equal to 9. Let's put negative 9. And number 5, just for now, is less than. So there's your 5 questions. And then let's go through the answers, just like we normally would do. So if you're still having a hard time understanding the equations part, I actually have some kind of way that will help you. So on number 1, remember, think of this as your equation. Put that line down. Kind of keep that barrier. Well, how do we solve for x? Well, what's the opposite of multiplication? Division. Okay. So negative divided by a negative, is that positive, correct? So it's going to be x is, what, negative 2? I want you to be very careful. This is kind of like another part of this. When you divide or multiply by a negative number, it's going to change your inequality. So please put this for now. It's going to change your inequality. Okay? So make that note. And we'll do some more, but I want to kind of leave it towards the end so we kind of get used to it. Look at this one. Put our line down, and then what? Well, this time you're going to just divide by 4. Divide by 4. But guess what? This is going to be x, but this time the inequality stays the same. And then you still get 2. Do you see the difference? If not, rewatch this again. But we divided by a negative number. When you multiply or divide by a negative number in the inequality, it changes the direction. And I will prove that later. But I just want to go through a few problems to kind of get this going in your head again. Look at number 3. Here's your line. What do? Divide by 6, right? And we got x is, did we divide by a negative? No. So we're going to go just keep it, and it should be -2. Okay. Look at number 4. Do you remember how to do this? It's a little bit longer, but here's your line. What do we do first? We're trying to solve for that x. So maybe you can remember this, that we're going to add 7 to both sides. And then that -4x goes here. We still have that greater than or equal than. And then we have, what is that? 2? Now what? Well, look at this thing. Remember this? Negative and negative? When you divide by a negative, you're going to change the inequality. But this is going to be 1/2. Okay. Look at number 5. But that, what do we do? Divide by negative. So in my head, I remember he said, is if I divide by a negative number in an inequality, it's going to change the sign. Okay, there's your answers. So, what if you don't believe me? One way you can do this is check your answers again. When I mean check your answers, let's go back to number 1, where it all started. Let's go back to number 1, where it all started. So let's do a little check. Our answer is less than 2, correct? What number is less than 2? So what numbers are less than -2? Well, we got -3. We got -4, -5. Well, be very careful. Don't write it like this. Write it in your integral notation that I taught you a little bit ago. What I mean by that is that this goes -3, -4, -5. Where can I go? Where can I go? All the way to -infinity. Okay. -infinity is not yet defined as a number, so we can't really include it. So what we can do is do something like that. We can't include it because it's not really a number yet. And then it says -3, we cannot have -2. So, but can we put -3 in there? Yes, we can. And there's where your integral notation, well, this is yet almost integral notation. I need to do one thing to make it efficiently integral notation. That's what I need to do. Take out the 2 middle. And now if you put this together, that's your integral notation. Okay? So let's test this and check it. These are all the numbers that I can check to make sure this is a true statement. So let's do it. Where do we start with this? Well, here's what I'm going to do. I'm going to erase everything and go back to the original problem. Isn't that my original? Now I'm just going to do any of these numbers that I have in my integral notation. So let's do -3 because it's there. So here we go. -4 parentheses greater than or 8. So what do we put it in there? -3, right? What's a negative times a negative? Positive, right? Is 12 greater than 8? Wow. So yes, true. Are you joking with me? Eh. -4 greater than 8. So what else can we put in there? Let's just jump the gun a little bit. What about -10? Let's see, that's negative times a negative is a positive. That's 40 greater than 8. Oh, that's true. So what I'm trying to show you is that by doing that switching of the inequality, when we divide by a negative number, it makes our equation now true. And the reason that makes it true is because it's one operation when we change the directions and when we multiply or divide by a negative number, sometimes it switches the problem around. And that's pretty much the simple explanation of inequalities. For inequalities, it changes the direction because it's doing like the opposite effect. So I don't want to make this video so long that you get bored with it, but I do like to go through a couple more long examples to kind of see if we got this intact. So I'm going to erase this. Okay. So let's go ahead and try this one. We got 2x plus 7 less than or equal to x minus 11. I think this was number 6. So this is our basic equation. This is an equation, well, inequality, but it's like an equation. But maybe you don't like dealing with the inequalities. So some students, they might do this for now. They might do this to kind of get them not, but we know, just make sure you note that this is less than or equal to. Just make sure you know that, because what I'm going to do might surprise you. What if I take that out and put an equal sign? Can I do that? Of course you can. Just remember, when you're at the very end, make sure you put that back. So here we go. I'm going to leave it like that because I know a lot of you remember how to do this. So here's our line. So remember, we have to get the x's together. So I've always been taught to take my lowest x. So x, x. And now on the side, I have, what's it, x plus 7 equals negative 11. Now, I'm going to get x all by its lonesome. So I'm going to subtract 7, and then I'm going to get x equals negative 18. Okay, I didn't do any dividing or multiplying by a negative, but remember, I told you, if you're going to change that into an equal sign for your answer, put it back. So make sure you put it back. Now, write this as interval notation. So remember interval notation? So what is less than negative 18? What numbers are less than or equal to negative 18? Well, what numbers are those? Well, you have negative 18. That's one. Could be equal to. What about negative 19? What about negative 20? What about boom, 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 negative infinity? Okay. What about anything else this way? No. So we're going to close that down. But then remember, I told you interval notation doesn't include all these other answers. They just include that right there. So that's your interval notation. Okay? So everything in this solution set will satisfy that equation. Now, what are these are good for? Well, inequalities are good for a whole bunch of things. When we went through inequalities earlier, we did some applications. We will do that later. But just right now, let's get the priorities down. So let's do maybe one more. This is number 7, I do believe. There you go. Now, solve for the unknown. Okay, what you could do is that maybe you're bothered by that inequality. Well, just remember it's less than and treat it as an equal sign to help you out. So here's your numbers. And here we go. So first thing to do is combine stuff. I can't do anything over here, so I'm just going to rewrite it. Can I do anything over here? Well, I can distribute. So I have 2x minus 6. Okay. Now what? Get the x's to both sides. So subtract 2x, subtract 2x. Did I multiply or divide? Not yet. Well, I never did it at all. So I don't need to change anything. So what we're going to do, we're going to go ahead and go, oops, this is negative, negative. Remember, minus minus is negative 7x plus 7 equals negative 6. Now what? Well, combine the 7, or take away the 7, because we're trying to get the x by itself. So you're going to subtract 7, and now you get negative 7x equals, for now, and that is what, 13? Okay, here's the objective. Be very careful now. Remember that equal sign we switched out? Why don't you put it back in? By the way, you don't have to do this part. You don't have to do this switching out. It's just for the students that have a little bit of trouble. So put that back. Now, what's going to happen when we divide by that negative number? It's going to switch things around. And then 13 over 7. Okay. Please write this in interval notation. So it's x is greater than now 13 over 7. What's greater than 13 over 7? Well, we don't need to do that because we already know what we're doing. We can't have anything negative that. So you're going to go like this. I would go 13 over 7. And what way are we going to go? We're going positive, so we can have more numbers. But we can't have anything, we can't have it equal this. So we're going to put a parentheses. And we're going to say, well, we can have bigger than this fraction. So we can go where? All the way to positive infinity this time. And then, there you go. You can't include infinity. So there's your interval notation. All right. I highly recommend going back through this video, getting those basic foundations down, because this can be hard or can be easy. It depends on how you study for it. But it really depends on you. But I really encourage you to watch this again, and don't forget your skills that you learned in recent topics that how to solve an equation. Okay? So, hope this helped. Have a good one.